The Mark III, more familiarly known as the Fat Man, was our first implosion-type atomic weapon. Its prototype was first tested at Alamogordo, New Mexico in 1945, and later a Mark III was used operationally against the Japanese city of Nagasaki. An improvement of the Mark III, the Mark IV, developed after World War II, was our first atomic weapon to be produced on an assembly line basis and to be stockpiled in large numbers. To give better ballistic accuracy, the shape of the case was changed. Provisions were also made so that the nuclear core of active material could be inserted without complete disassembly of the weapon by the use of a special detachable device. This gave us the capability of in-flight insertion of the active material. The firing system, commonly referred to as the X unit, and the fusing system were also improved and mounted on a cartridge to facilitate checking and testing. The Mark VI looks almost identical to the Mark IV, from which it was developed. But inside the 61 by 128-inch aluminum case, many changes have been made. Below the safing plugs, an easy-to-remove nose plate permits access to the horn-type radar antenna and allows for simpler and quicker in-flight insertion. Redesign of the entrance to the pit, addition of a detonator-holding trapdoor, and coring of the high explosive makes it possible to slide the outer and inner cores of HE into a rotatable holder and permits manual IFI to be accomplished in a minimum of time. A single lug at the top of the ballistic case is used to suspend this 8,500-pound weapon from the bomb bay of the delivery aircraft. And extending through the skin are the arming wires that operate the pull-out switches upon release. This easy-to-remove cartridge is the electrical and electronic heart of the weapon. Readily accessible are the batteries, the radars, and barometric switches of the fusing system. The gap tubes and detonator contacts of the X unit are on the face of the cartridge, and inside the weapon is the detonator distribution system, with its loading coils to equalize the electrical paths to the detonators. When the cartridge is inserted in the weapon, pressure contact provides the connection between firing system and the terminals of the detonation system. In contrast with the Mark VI, which requires manual insertion of the nuclear material, the Mark V has a built-in mechanism to perform the insertion of the capsule and the cored high explosive. Thus, by a switch on his in-flight control box, the bomb commander of the delivery aircraft can automatically perform a nuclear insertion or extraction at any time. After the cartridge has been checked and installed, the tail section is attached, completing the assembly of this internally carried weapon. The need for a tactical weapon led to the development of the Mark VII. The two-piece ballistic case that encloses the components of the weapon give it the required streamlining to be carried externally. The Mark XII weapon, also designed to be carried externally, is even lighter and smaller than the Mark VII. Our above-ground capabilities with the implosion-type weapon are numerous. The Mark IX artillery-fired atomic projectile is for use in the Army's 280-millimeter gun. Thus, from our little boy and Fat Man, as new ideas have developed and as technical hurdles have been surmounted, our family of atomic weapons has grown. and will continue to forge ahead to meet the needs of modern warfare.
When the Department of Defense requirements for new or improved atomic weapons have been met, the various manufacturers under contract to the Atomic Energy Commission establish production of weapons and component parts for delivery to the designated AEC and military storage sites. Their arrival at one of the storage areas is not, however, the end of responsibility for either the AEC or the armed forces, but rather a continuation of the coordinated teamwork and concerted effort that made the testing, development, and production of war reserve weapons possible. The stateside sites or physical facilities where the weapons are stored may be under the operational control of the field command of the Defense Atomic Support Agency, as in the case of our national stockpile sites, or in operational storage sites operated by the logistic agencies of the Air Force, Army, or the Navy, and commanded by these services. The services are also in command of smaller storage sites, which are located throughout the world. Each site within the zone of interior is manned by a one-service organization. It is considered that from an operational standpoint and for administrative purposes, a single service organization is more efficient. A large segment of the organization's manpower is assigned to the task of providing security for the area. Patrols must be maintained around and within the multi-fenced perimeter. The Atomic Weapons Organization's highly trained technicians are charged with the important mission of inspection, maintenance, assembly, test, and modernization of weapons stored at the sites. These men, who ensure that our atomic weapons are ready if and when needed, attend specialized training schools. All of the services conduct training in phases of the atomic weapons program of particular interest to that service. Field Command, Defense Atomic Support Agency, Atomic Weapons Training Group at Sandia Base, Albuquerque, New Mexico, conducts individual training for enlisted and officer personnel for the Army, Navy, and Marine Corps, and for personnel assigned to Field Command. Unit training is also conducted for personnel of the Army and Marines. The courses of instruction conducted by Field Command, DESA, provides individually trained nuclear weapons technicians for the Army and Navy. Also, personnel are given additional training in the highly technical aspects of radar and test equipment operation and repair. Unit training is provided for Army Ordnance Special Weapons, General and Direct Support Units, and for Air and Ground Marine Corps Tactical Support Assembly Teams. Air Force personnel receive all phases of weapons training at Lowry Air Force Base, Denver, Colorado, similar to that received by the other services at Sandia. Whatever their ultimate assignment in support operations, it will be trained atomic weapons personnel like these that will conduct the final preparation of our atomic weapons for their delivery on target. With respect to the storage of our atomic weapons, we find that the older weapons may have to remain in stockpile for an indefinite time, in which case, to guard against deterioration and to ensure that each weapon meets DoD reliability criteria, it is given periodic storage monitoring checks, ranging from limited inspections, where only certain components of the weapon are tested, up through a quality inspection of the completely assembled weapon. Commencing in 1956, a technique of packaging certain nuclear components at the time of manufacture was developed. These components require only limited inspection and testing prior to their use, and may be stored in operational configurations ready for immediate dispersal. Depending on the urgency of a combat situation, various weapon configurations are available. If time is an important factor, a weapon that has been in a ready storage condition may be selected for use. At a later phase of a war, an older weapon, which is in controlled retirement, may be selected. In such a case, the components of the weapon are checked for dependability by the atomic weapons personnel within the stockpile site before it is turned over to the using service. When operational experience or research bring about improvements in stockpile weapons, costly and time-consuming return of weapons to the factory is often avoided by in-the-field modernization and modification changes performed by these specialists. A major portion of inspection, maintenance, and modernization responsibility falls upon the shoulders of these atomic weapons personnel, who, whether at a storage area or assigned to an operational atomic weapons unit, are entrusted with the mission of preparing our atomic weapons for ultimate combat use. Thus far, we have discussed the phases of operations which can be referred to as the mine-to-stockpile sequence. We will proceed from this point with the stockpile-to-target sequence. Although air transportation is normally used, a weapon may make its trip to the forward staging area by various means, depending upon the particular priority and need of the service that is to ultimately use it. Dealing with the services individually, let us look at the Air Force first. A weapon to be delivered by the Air Force, depending on the physical facilities available, is loaded directly aboard the strike aircraft. A final inspection team can make the desired fuse settings and quickly run a functional test on the other components. Perform a post-loading check to see that all connections are made correctly and the weapon is ready for its mission. Where our smaller and lighter weapons are to be employed and the tactical or air defense situation demands, the weapon selected for use may be assembled at the stockpile site and the final and post-loading checks completed in the forward area by the personnel of an atomic weapons unit. Thus, by following an established plan, and with the use of an intercontinental bomber or missile as a delivery vehicle, we have, in the matter of hours or minutes, the capability of delivering an atomic weapon on target any place in the world. In addition to the aerial delivery punch of the Air Force, the United States Navy's formidable aircraft carriers today have the capability of launching atomic strikes. These highly mobile airfields receive their weapons in an assembled condition from strategically located storage areas. Once aboard ship, the weapons become the responsibility of the Weapons Division, which has the capability of storing, inspecting, assembling, and the final testing of weapons prior to their loading on strike aircraft. These units, whether they be Navy or Marine Corps, who may support both shipboard or shore-based Marine squadrons, keep their personnel in top efficiency by continual training and proficiency checks. In addition to its carrier-based delivery capability against land, air, sea, and undersea targets, the Navy also has a submarine and surface-launched guided missile capability. With respect to the Army, and to complete the overall picture of Department of Defense capabilities, Army Ordnance Atomic Weapons General and Direct Support units have been provided to ensure efficient support in the stockpile-to-target sequence for atomic artillery shells, guided missiles, ballistic rockets, and atomic demolition munitions. The supply of Army-fired atomic weapons from the ZI to the using units is a function of specially trained ordnance units. The ordnance units may issue atomic weapons and nuclear components to artillery units at designated ammunition supply points. These units may be depots for storage of relatively large numbers of weapons for an entire theater. Or they may be support units maintaining ammunition supply points in support of field armies and corps. Or they may be small teams for limited or special applications. The nuclear components, projectiles, and warheads may also be with the firing units, such as Nike Hercules air defense batteries in the ZI and abroad, or various other artillery missile and rocket batteries. In these cases, ordnance maintenance teams will provide support. To sum up briefly, it might be said that the Defense Atomic Support Agency and the services train the skilled technicians who then join service or DESA organizations to prepare our atomic weapons from stockpile through the various and sometimes complex operations of making them completely ready for the day when presidential decree may send them against an enemy by Army and Marine artillery units, aircraft carrier strike, other Navy ships, by tactical aircraft, intercontinental bomber, and by guided missiles.